All right, students. So today we are going to work upon a Numpy, that is numerical Python library, and this is an open source library for the Python programming language. Okay, for example, if you want to work upon linear algebra, if you want to work upon data analysis tasks, numerical computations, then this library is very important library. And what I believe is this library is the basic or the foundation library to work upon the data analysis in case of machine learning and data science. Okay, and what I know is you have already told, sir, we did worked upon the Numpy. So, can you please let me know what you have done in this Numpy? What functions you know about Numpy? You have already solved some exercises based upon it. So, can you please let me know what is Numpy doing, and why we are including this Numpy in our learning? Okay, so please let me know what is your idea, Numpy. You have worked upon this library.
Yes, sir.
Okay, so what you have learned in this library? What exercises you did? What are the functions?
Numpy arrays, sir.
Okay, NumPy array. All right. So basically, it deals with a multi-dimensional array. Okay, so whatever the operations we need to work upon the multi-dimensional arrays, NumPy provides a support. All right. So here, as I told, it is an open source library, so you can install it easily. Okay. And after installation, you can perform numerical computation and data analysis tasks. Basically, numerical Python is going to work upon the arrays, matrices, especially multi-dimensional arrays. Okay, and also it is having the functions, already inbuilt functions, which can work upon the linear algebra, random number generation, and Fourier transforms. This is related to the mathematics. So, what are the mathematics which we can apply over your this numerical computations that are all supported by the NumPy library, and it is widely used in scientific computations. Okay, so here the applications. If I do talk about the applications of NumPy, I already told scientific computing, data analysis and the visualization, machine learning and the deep learning, signal processing, image and video processing, optimization problems and linear algebra, random number generation and high performance computing. So, whatever be the maths you are going to apply, all important formulas and applications are available in NumPy. Okay, so that's why this is a basic of fundamental and important library for our data science and machine learning. Okay, and we are here to work upon, in case of data science, we are usually having the tasks related to the linear algebra. Okay, linear algebra, if I do talk about linear algebra, it is a branch of maths which deals with the linear equations. Okay, like vector spaces, matrices. So we formulate our problems on the basis of your matrices and the vectors, because in most of the cases, if I do talk about machine learning, deep learning, or this data science things, we are having the equations which are represented in the form of a matrices and the vectors. Okay, so obviously we need to either calculate addition, multiplication, determinant. Okay, we need to find it eigenvalue, eigenvector. Okay, so there are many stuff which we are in a requirement to calculate. All right. So this NumPy library provides a comprehensive set of functions which can operate over the linear algebra, and it is having LINALG, that is linear algebra module, already inbuilt module present in the NumPy, which can perform matrix inversion, matrix determinant calculation, eigenvalue decomposition, singular value decomposition, and many more. Because most of the problems based upon this data science and machine learning requires matrices. Okay, and we need to perform transformations over the matrices. So here, in case of NumPy, we are already available with a predefined method which can perform all those transformations, and we can solve our problem easily. Okay, so that's why I'm repeating again and again, this library is a very very important library, and it do Numpy, basically Numpy array, as the student told, sir, we have learned some, we have done some problems related to the Numpy arrays. Okay, so apart from this all matrices and determinant and calculation and doing all such tasks, Numpy arrays can be used to represent the matrices, because if you want to represent a matrix, so arrays can, Numpy arrays can be used to represent the matrices. It can perform matrix operations. Okay, that means already there are available functions in the Numpy. So finally I should conclude that Numpy is a powerful tool for linear algebra. Okay, and it has a wide scope here. So whatever the be the maths, whatever be the numerical computation you want to do. Okay, in the previous lectures we have learned about the Python. Okay, and in the fundamentals of Python we have seen, sir, we can, how we can declare a variable, how we can perform iterations, what are functions. Okay, that means conditional statements we have also covered, functions we also covered, we have checked about the classes and object concepts also. Okay, then we have seen inheritance. All right, then we have learned about iterators, file handling. Okay, many stuff we have learned, okay, related to the Python. But it's not limited, actually Python is not limited. There are already other libraries also to perform the computation or the task. Okay, so if I do talk about numerical computation, so Numpy is here to perform the numerical computation. However, some simple computation we can perform in in general Python also, addition, subtraction, and all this thing. But there are some certain methods which are available in the Numpy under some module, under some library. Numpy is one of the library where the complex numerical computation can be done easily. Okay, so that's why we are going to check out this library, and we will be doing a lot of codes here, and let us understand one by one. Okay, so I hope you know how to install Numpy. Okay, because as you have already used and it is open source. So after installing Numpy, we are having some codes to work upon. Okay, so for that you need to import Numpy. Import. See, import Numpy as NP. We need to import a module in our code, then only we can apply its operations. Okay, so here after installation of the Numpy you need to import Numpy, and I am saying import Numpy as np, that is numerical Python, or it's up to you what short name you can give to this particular library while accessing its operations or the functions. So if I say import Numpy as np, so it's a general notation. You can use import Numpy as your name also, it's not a big deal, I've already told previously. Okay, but the point is we are just using general notation. So importing library is important, and after the import of this library you can use its functions. And NP is an alias, that is it's a name given to the because I don't want to use numpy again in my code. So the good thing is just to use a simple name, a short name for this library, and operate on its methods. Okay, so after importing this library, what I did, np dot array 10, 12, 14, 16, I gave some elements. That means this is a list, this is a list of certain elements, and I gave this list to the Numpy array. Okay, I gave this list to the Numpy array, and what is my goal is, what is my goal, my goal is to create Numpy array from list. I'm going to create an array. Okay, and you have already studied about arrays in Python. What are arrays? Sir, arrays are this is a data type in which we used to organize the elements into contiguous memory allocation, sir. And sir, indexing start from zero, sir, and they are homogeneous in nature, sir. Okay, so these are certainly the properties of an array, and here we are creating a Numpy array. Okay, Numpy array. No, not a simple array. Numpy means something, an array which has been created on which we can perform numerical computation. That kind of array has been created here. Not, I'm not talking about a simple array. Okay, but the property, as you know, that will be all the same. So here there is a list of elements, and I will convert it into array and assign it into a variable that is called as my underscore array. assigned this value to it, and then I have printed. Okay, here it is. So this is an array. This is an numpy, though it's looking like 10, 12, 14, 16, 20, 25. It's like a list only. It's looking like a list. However, it is an array now. I've converted it into array. And then what's now happen next? What is the data type? I'm going to print its data type. So it's integer 32. Int 32 is the data type of this array. Okay, so we are having int 32, int 64. Okay, that means all these are integer values which are in a requirement, which are using 32 bits of memory for its storage. If this thing is been stored in the memory, they are requiring 32 bits. And what is 32 bits? We know 1 byte is how much? 1 byte is how much? 1 byte. How many bits? One.
8 bit.
8 bits. So in the
Eight
next,
bits.
yeah, in the next case, I have printed something more. My array dot data type dot item size. That means 4 bytes. Okay, so here d type dot item size attributes return the size of each element in bytes. Okay, and above one is representing the data type, so all are in integer 32. Okay, and here I am returning that each element, what is the size of each element here? So the size of each element here is 4 bytes, and 4 bytes itself means 8 fours are 32, so 32 bits of integer type. And this is an array. So just right now we are learning, okay, what is numpy array, and how to represent, what is the data type requirement, what is the size requirement. In the next case, sir, here I took your what values, integer values. Okay, let me copy this code. Okay, and now let us take the values in floats. Okay, let us take 10.5, 12.5, okay, 14.7, okay, and then 16.10, okay, and 20.8, and 25.123. Okay, and now let me run this code. Now it is saying, see, scenario changed. This is again an numpy array, but now the data type is of float 64. 64. So 64 means this is a floating point array, and every element is taking 64 bits for its representation. Okay, and 64 means what? What is 64 means? 64 means 8 8 is a 64. That means each element requires 8 bytes for its storage. Then only it will convert into 64 bits. Everyone, each and every element. Okay, so previously I was using your int values, and now I have converted them into floating point values, and the scenario changed for the storage. It's not float 64. Now you will say, sir, what will happen if I do use this string values, sir? If I'm having red, green, orange string values, now kindly do we convert it into array? Yes, we can convert it into array. So it will be an array. Then can you, sir, tell me what is the data type of this thing if we have converted into array? See, the data type is U6. Can anyone tell me what is this U6 means? What is this U6? U6. See, it is a Unicode string, because obviously this is a string now. So U6 means it is a Unicode string of length 6. Here the length of the string is 6, so I am representing the length of the string also. Okay, so here it means it's a Unicode string of length 6. Okay, that means a string is represented in some codes. Some So that code is a Unicode. Okay, when see, when you write something on notebook also, in some text file, if you prepare a notebook, there is some what is the type of that particular thing. So it asks Unicode, ASCII. There are some standards in which that particular information data is stored. So here U6 means it is a Unicode string with a length of 6. Okay, and what is the item size? What is the item size? The size of each and every item is 24. Okay, so if I divide 6 That means if I divide 6 to the means to the 24, so 24 and 6, how much it is? 24 by 6, how much it is? 4 za 6, 6 4 za 24. Okay, so how much storage each and every element is taking here? How much storage each and element is taking here? That means the size of each element in bytes. So each element is taking 24 bytes here. So how 24 bytes for their storage here. Previously when we were working with this float, each element is taking 8 bytes. When we are working with the integer, each element is taking 4 bytes. Okay, and here if I do talk about the string, unicode string, each element is taking 24 bytes for its storage. Okay, now this is your string thing. Now if you say, sir, can we mix up, what is the possibility? Okay, let us check. Can we create a mix array, for example red, green, orange? And is there any possibility if I do write 12 and if I write 67.56? Let us check what is the possibility. Run this code. Okay, it it is also possible. That means now I found that this is your array. See, Python gives you a lot of flexibility. And we have already seen, sir, this is a list, na, sir. And list can comprises of any kind of values. List is a mixture of any kind of values. It's not mandatory, it is homogeneous, it is heterogeneous. And we can create by this list. Now you can see, sir, the definition which you have learned of array, sir, it is a homogeneous collection. Who says this is a homogeneous collection? Are you looking that this is a homogeneous collection? No, this is a string, this is an integer, and this is a float. Is this a homogeneous collection? No, not at all. This is heterogeneous collection. Okay, so array is heterogeneous collection here in Numpy. It's possible. And if I do talk about the data type, data type is Unicode string with 32, and the each element is taking 128 bytes for its storage. Okay, so again the things change if you are mixing up. Previously when I am available with only string, then 24. Now if I am available with a string and the numerics, then it is having u32, unicode string 32, and 128 bytes for each and every element storage. Okay, in the next case, sir, let us do some more changes. Now I am going to take what? Dates. This you can see dates. Okay, that means year is also there, month is also there, and day is also there. Now if I would say convert this thing also in array, yes, it did converted. And if I do talk about the data type, it is again unicode string u10. It is a unicode string 10. That means what? That means what? Means it is a unicode string of length 10. Length is 10, and each and every item element size is 40 bytes. Okay, so here this is also taking 40 bytes. This is also 40 bytes they are taking. Okay, and it is a unicode string of length. What is the length? 10. All right, so this is how we can represent the dates also in array. Now if I would say, sir, my array, this is my array, this is in form of your date, complete date. If I want to say convert this into my array dot s type m, convert this into s type means I need to convert this array into some type. I need to convert this array into certain type. So s type m. Okay, and what will be this m is? Is it month? Is it year? Or is it day? What actually it is? S type m. S type m. What actually it is? What do you think? Is it a month? Is it a year? That means are we filtering our data? Are we filtering our data to some respective month or what? What do you think? S type. See, Here we have used S-type method to convert data type into numpy array. Okay, and here what you got, what is the output? You got the output as, let me run this code, numpy array m error, there is a parsing, there is some issue because I need to run this thing first. Okay, and then this thing. Now the output you got is date time 64. This is date time 64 output you got. Okay, and previously when I was dealing with the item size, the item size was 40. When I'm taking year also, month also, and a day also. Now you say, what is the item size? Now the item size is 8. Item size is 8. Previously item size was 40. That means I have filtered my data and I am only considering the month here. I'm only considering the month here instead of taking the year and a day. Okay, so that's why here the here the data type is again a date time format. Previously, now remember one thing. Previously it is an array. Okay, now I have converted this array into date time format. Date time 64. There's a change. So S type is a method which is used to convert some format into another format. So my array was previously is an array. Here it was declared as an array, and now I have converted this array into date time format. Okay, so here it is in a date time format, date time 64. Okay, and it's saying that the size of the items, the size, each and every element, here it is taking what is the size. The size is 8. Okay, and if I need to print it also, let me print it, copy this thing, and I want to print it, then I will check what is the data type and what is the item size. Let me print this thing so you can see. Okay, this is your S type. Okay, S type, your date time, it has been previously it was an array, now it is in a date time format, and it's been printing date time 64. Okay, and it's saying now each and every element is taking 8 bytes for its storage. So with the help of S type you can convert from one data type into another data type in case of numpy. For example, if you are available in integer, you can convert it into float with S type. Okay, and you can convert it into string with the help of S type. Okay, so here it means that you are going to convert this into datetime format m I have taken here, and it's printing its data type and it's printing its size also. Okay, and very important, we can't ignore this code, very important, because if I need to convert something into date time format, because the reason is in your data when you are going to perform the projects in your data, obviously some other problems are having this kind of entry available for the dates. Okay, so we need to convert it into date time format. Okay, and there are other methods also to convert it into date time that we will check ahead when we are going to do the projects. Here again, if I would say my array equal to np array, this and just writing this thing into another way of doing this code into another way. That means I am available with the array. This is your array of elements. Okay, and then I'm taking data type equal to m, and then I'm printing it. Okay, so again it is converted into date time format, and here I'm printing the item size also. Okay, so both the codes are same. Here I have used S type method, and here I used that this is an array, and data type should be m. Okay, so it's converted into date time format, and here we got the result. Everything is same. Now, uh, just a very simple thing to understand. Again, I have created a list. Okay, so the first thing is you import your Numpy library, and I have created a list. And I have given list as an argument to np array. Okay, and this is an array, it will be converted into array. Now if we are going to print, what is the type of it, what is the type of, so I have already told it is a numpy works upon multi-dimensional arrays. Numpy works upon multi-dimensional arrays. So if we do print the type of an array, so it will be numpy dot nd array. n dimensional array. Okay, so if in general, or if in a very simple, you just say, you just create a list x equal to 1 comma 2 comma 3 comma 4 comma 5. Okay, and if you convert it y equal to np dot array. Okay, and you just take this list as an input, and if you print, what is print y, what is the value of y. Okay, and if you want to print what is the type of y, what is the type of y. Okay, and here the good practice should be import numpy as np, import numpy as np. Okay, and if I do run this code, here is your numpy array, and here is your, it's representing the class numpy nd array. Okay, here it's representing the class numpy array. If I do write only type y, then it will return only numpy nd array. If I write print type, so it's a class, basically it's a class numpy nd array. So there is a difference. Someone may ask you, what is the output of this code, and what is the output of this code. If you write print type y, then it will say class numpy nd array. If you write only type, then it will only print what actually it is. It's a numpy nd array. So n dimensional array we are going to create here. All right. Now, if I would say, sir, can there is a possibility to create an ND array with the tuple also? Now let me copy this code. We just try to do experiments. Sir, can you take a tuple, sir? Okay, let's take a tuple. And then can you create an array on the basis of tuple also? Let me run this code. Okay, now check. If you are going to work with the tuple also, now it will convert it into the array. This is an array, and all the things will be same. That is numpy nd array. Sir, can you take it in the form of set also? Can you take elements of set and convert it into numpy array? For example, if I do take like this, set, create a set, okay, set of elements, and convert it into array. Okay, see what happened. Though it is a ND array, but can you check the representation here? Now your array is, it's been organized in a form of set. Previously, when you took list, when you took list, then also it is represented in a form of a list. When you took list, then also it was a list. Okay, when you took tuple, then also it was a list. But now when you took set, now it is represented in the form of a set. However, it is a numpy nd array only. It is array only, it's converted. Okay, now you say, sir, can you do experiment with the dictionaries also? Is there any possibility that you can convert a dictionary into NP array? Okay, come on, let us do it. So one, if I would say a colon 1 comma b colon 2. Okay, just create a dictionary. Then c colon 3, then d colon 4. Okay, and then e colon 5. This is a dictionary. So, sir, is there any possibility to convert dictionary into numpy array also? Let me run this code. It's a invalid syntax because I have used here comma, semicolon. Now it's a colon. Now let's see how much flexibility is giving. If you are available with the list, if you are available with the tuple, if you are available with the set, if you are available with the dictionary also, it will convert it into array. No worries at all. And now if you want to, sir, kindly show the sir, what is the data type, and what is the item size, sir? Is there any possibility, can you print the data type and the item size also for that? Okay, let us print the data type also. Print y d type, and print y d type item size. Can you please tell me? See, it is of object type, and each and every element here is storing 8 bytes. Okay, so this is also 8 byte, 8 byte, 8 byte, and it is of object. Object means it is a string only. Okay, but not Unicode string, simple string. Previously you are getting the U6 Unicode. It's not a Unicode string. That means each and every data storage is having some encodings, how they are stored in the memory. So here it's just a simple string object. Sir, can you do this thing with the above code also? Can you paste it here and let us know what is the data type of and what is the size of it? Okay, again it is object 8 bytes. Okay, here what is the possibility? Okay, let me run this code again. Okay, here integer 32 4 bytes. This is integer with the 4 bytes of storage. Okay, what about sir this thing? Let's check again integer 32 with 4 bytes storage each and every item. This I already told. Okay, so here are the scenarios. If you are using set, then it will be an object, and if you are using dictionary, again it will be an object with 8 bytes only. Okay, so these kind of codes are not available anywhere. While teaching, these things come into my mind, and we just do this thing practically also. Now please let me know, do you have any doubt? Any doubt, students? Please let me know what you understood and what you didn't understood here. Please, I want some
No
interaction
doubt,
from your
sir.
side.
No doubt, sir.
Okay, so are you understanding Numpy? What we are doing? See, just right now we are checking the general cases of Numpy. We haven't applied any big operations here. We are available with the list. We gave input as a list. We are available with the set. We give input as a set. And all this, we are just putting the data inside this np dot array and printing what is the data type, what is the size. That's it. Nothing else we are doing. Okay, let's proceed ahead. Now, if I do take three list in the array, row 1, row 2, and row 3, three list in an numpy array I'm going to take. Here it is. Row 1, row 2, row 3. So what actually it is? What actually it is? I am taking this list 1, list 2, and list 3. Inside this list 1, list 2, list 3, inside a list. Okay, so do you understand what actually it is? If I print it here again, if I print here nums underscore, it's saying 2d underscore 1. For example, if I write like this, and if I copy this complete structure, okay, copy and paste it here. Okay, so row 1, what was row 1? Your row 1 was this thing. Okay, now I will help you in understanding what is, how to find the dimensions also, how to understand what is the dimension of your array, because numpy is already working on multi-dimensional array. It's been built for specifically for multi-dimensional array, because unidimension is something easy, but working on multi-dimensional is tough. Okay, so numpy's will this library is going to help you for that. Now I have put the value of row 1, row 2, row 3 here, and you should understand what is the shape of it, what is the dimension of it. So you can see how many elements are here. Three elements, three elements, three elements. Okay, sir, three elements are there. All right, so if I go to print, kindly print me, print this thing, print this thing, and then I'm going to take out the shape of it. So let me run this code. This is how it's printed. So after seeing this, I found, sir, there are row 1, row 2, row 3. Sir, there are 3 rows, na sir? And how many columns are there? Sir, column 1, see, this is first column, this is second column, this is third column. That means I am available with a matrix. It's like a matrix which is having 3 rows and the 3 columns. And also, how many? See, here there are 2 brackets. Here also 2 brackets. So understand, if you are available with these brackets like 2, that means it is a 2D array, and its shape is 3 row and 3 column, so 3 cross 3, so it is a 2D array, and I can say it's a 3 cross 3 matrix. Understand this. And how you found it's a 2D? See, if I'm having two brackets here, two brackets here. It's a 2D. Now you will say, sir, any modification you can do with this thing. Copy and let me paste it here. If I put one more bracket here, one bracket here, and one bracket here, now it will be converted into 3D. By these three brackets, these three brackets. Now it will be 3D. Let me run this code. Let me run this code. And you see, shape will be like only this thing only. 3 rows and the 3 columns. And I have printed this matrix. I printed this matrix and its shape is 3 cross 3. But actually it is not 2D. It is not 3D matrix. Okay, and in our upcoming codes, we are going to print the elements also. We are going to check the dimension also. But I have made you aware initially only. If you are available with number of brackets, these are 3 brackets, these are 3 brackets. Understand this is a 3D matrix. Okay, so here is let me change its what I printed. Okay, let me change here is to 3. It's a 3D. Okay, and this is 3D. Okay, and if I do print the shape 3D underscore 1, print its shape. Okay, so now check out it is 133. Hope you understood. I was saying 3D, but you should told me, sir, you here you are printing 2D stuff. Kindly print 3D underscore 1 stuff. So you can see this is also one dimension, one dimension, one dimension. 3 dimensions are there. That's why I told you it is a 3D matrix. Okay, that means one additional dimension added to your matrix. Previously, if I print this thing 2D underscore 1, this thing shape. So its shape is again 3 cross 3 only. It's 2D. Right now it's 2D. Okay, but when I add one more square brackets outside, it converted into 3D. And here it is. Now if you say, sir, any more possibilities can be done? Yes. There are many possibilities can be done. If I say x equal to, if I say x equal to 1 comma 2 comma 3, and if I take y equal to np dot array, and if I do take like this, one bracket, one more bracket, and one more bracket, then I take x. Then I take x. Okay. So and when I'm going to print it, I'm going to print the value of y, print y, okay, and print shape of y also, y dot shape. I'm going to print its shape also. Okay, print its shape as I did above. Print its shape and print y also. Okay, let me run this code. Here this is your y, and here it is shape. So how many brackets are there? Bracket 1, bracket 2, bracket 3, and inside x there is one more bracket. So it's a 4D. This is a 4-dimensional matrix. And here is the size of it. So there are 3 elements present in the row number 1. See, understand how to interpret this. In row 1, 3 elements are there. That means 1 row and 3 columns are there. And outside there is one more dimension, and outside there is one more dimension. One dimension additional outside. Let us interpret this thing. There are 3 rows and the 3 columns. Additional 1 dimension is also there outside. So you need to assume in your brain how this structure looks like. This is a 3D structure, and we are available on a screen right now. What we are doing, this is, if I say it's a 2D thing, how can I represent 3D here? 3D means in x-axis, y-axis, and you need to create one more axis, z-axis. Okay, one additional axis is here. So it's representing axis, additional axis. Okay, and this is your 4D. That means 3 columns, 1 row. So this is end for this particular thing only. 1 row, 3 columns. Apart from that, you have created 1 1 1, these 3 additional access also. Okay, we will see, we will learn more ahead. Now I hope you understood something about this dimensions and shape, and we have printed it. But don't, no worries. We are going to cover most of ahead. Now, if I'm having np dot arrange 511, np dot arrange 511. So I hope you have already learned about range method. We have already seen range method, no? Using for I in a range 5 to 11. So this also works with numpy, but not only range. np dot arrange 5 to 11, it's going to print you the array elements from 5 to 10. Oh, obviously 11 is excluded, no? You know about it. So 5 to 10 elements are printed. So just remember np dot arrange method. Okay. Now if I'm saying np dot arrange 5 comma 12 comma 2, and you have learned this stuff also in range. 2 means 2 to gap. So if I'm taking first one is 5, then gap of 2, next element is 7, then gap of 2, next element is 9, then gap of 2, next element is 11. Okay, and 12 is the upper cutoff. We can't go beyond 12. Okay, so the 2 to gap. So here you can give the gaps. Same thing as we used in the range method. Same stuff we are learning. Again, if I say np dot once 6, np dot once 6, that means it's going to print you 6 ones here. Very, very important. Again, once, because you said now you are going to use numpy for numerical computation. Okay, so np dot once, that means it will create 6 ones here. Okay, it's an array, numpy array with ones. Okay, so and just see this data what you got, check the output also. Okay, and if I say once a dot shape, if I going to print, sir, kindly print the shape of ones also. What is the shape of ones? Let us check. Dot shape. Okay, it's saying 6 comma, that means it's a array. 6, that means it is a scalar quantity. Right now only I'm having, what I'm having, only this one particular row in which six ones are organized. 6 comma. Okay, now do some more experiments. What next experiment is, I'm going to take, okay, numpy, and here is your array 1 2 3 4 5. Simple numpy array. You created copy of this array, arr dot copy, and you said arr1 equal to arr dot copy. That means, okay, I've created a copy. That means all these elements will be present in now arr1 also. All these elements will be present here in arr1 also. And what I did, I perform a modification on initial array, and I updated the value arr10. Sorry, not arr10, it's arr0 equal to 42. I performed a modification here in initial array and updated its value from 1 to 42, and I printed both these array, arr and arr1. Let me check the code. I found that I found that there is no change in arr1. The changes which we made on initial array is only the array which got changed, and it's not, the changes are not reflected back to this array. Okay, so this copy method only creates a simple copy, not a reference copy. But there is one more method called as view. If I create a view of an array, existing array, so for example arr1 is a view of existing array. Here you have created one array, it's a view. And if I do change the contents of initial array, then the changes are reflected back to the new array also. You can see the value of arr and arr1, its values are changed. Okay, so this is the difference between copy and view. Okay, next I've used one more code for the view. Again, I took an array, the 1 2 3 4 5, these are the elements. I created a view of it, updated the I oh, okay, one more thing, sir, can we What you know what this code is? Previously, I did perform change on initial array. Here in this code, I perform change on new array, which has been created by a view. So if I do change in new array also, na, it will gonna reflect previous or original array also. So the point is clear. Both the arrays are view of each other. Both the arrays are view of each other. Either I will say ARR1 or either I will say ARR. Both are same. If any change in anyone, it will be going to affect. Now you will say, sir, can we do one more twist, sir? Can we have a twist? Kindly create third array, sir. Create ARR2 with ARR1 as a view. Okay. Now let us make a copy. Copy this line and make ARR2, which is a view of ARR1. And if I print ARR1, ARR1, and ARR2, whether the changes are reflected or not, sir, let's print it all. So I created ARR2 as a view of ARR1, which was initially view of ARR. And let me run this code. See, everything got changed. So you can create multiple views. Okay, but changes will be reflected back to every array. This is the importance of this method view. Now, another code. I created an array. I created its copy, named it as X. I created another array with a view, named it as Y. And I printed X dot base and Y dot base. X dot base and Y dot base. So, what does this base means? Here, I am printing the value of X and Y. And I found that it's none and its view. Same thing which I created previously also. ARR view and a ARR copy. But when I print a X previously, when I was working with your copy, when I printed this ARR, this thing, I got the array. Okay, but what happened here? I am printing ARR dot base. So what does this base means? And with a view, I got the complete Y. 1, 2, 3, 4, 5. But with a base, I haven't found this thing. I found none. So now what is it? It's representing. When you create a copy of any of the array, this shows that it's not been a part of its reference. Okay, so this is what a base actually defines. It's not be the reference. What is the base of that particular array which has been created? So here it doesn't have any base. X doesn't, because it's created by a simple copy. So it doesn't have any base. But whenever you create an array with a view, obviously it has some base. So this is a base of this particular array Y. And whatever be the changes done on Y or ARR, obviously it's gonna reflect it. That's why when I'm going to print the base, what is the base array of it? So this is the base array of it, of Y. But what is the base array of X? It said none. What is the base value? None. Okay, so the question will come, na, sir, how it is reflecting, sir? You will ask, sir, how it is reflecting? In copy, not reflecting. In view, it is reflecting. So because of this only, base. Okay. Um, in this example, next example, I've already told you shapes. If I do take np dot array 1, 2, 3, 4, 5, 6, 7, 8. Now, remember what happened. This is your list 1. This is your list 2. Okay, separated by comma. If I'm having list 1 comma list 2, that means you understood, sir, this is row 1, this is row 2. And how many elements are there in each row, sir? 1, 2, 3, 4. 1, 2, 3, 4. 4 elements are there. So what will be the shape? What will be the shape? Sir, 2, 4, sir. 2 rows and the 4 columns, sir. Okay, what kind of If I say 2 4, you understood, sir, 2 rows. And if I going to print first, let me print it. Print ARR. Let's have a print, then find its shape. Here it is. So sir, it's a 2D matrix, sir. It's a 2D matrix. Its dimension is 2D. What will happen if I do copy this thing? If we do copy this thing and don't take this bracket outside one, don't take this bracket. And now ARR and print its shape, it will give you error. Field elements must be 2 or 3 tuples, got 5. So you can't do this task, because if you separate it by comma, it should come into the next line and it should be like 2D. It should have to be 2D. If you try, sir, if I remove this outside brackets and now take it as so, no, it's not going to work. But it will work in this way if it has been converted into one dimension. How? If I put a comma here, now it is okay. That means now it is, sir, having 8 elements here. It's a 1D thing, 8 elements. But it will not tell you like 8 1, no, 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 or either 1 8. No, no, no. This is not the case. It's just a sample array with 8 elements. That's it. Okay. But if you perform this kind of operation, it's mandatory for you to put square brackets because it is a 2D matrix. You can't create 1D in this particular manner, just separated by comma, list separated by comma. No, not at all. You can't do this thing. It will give you error. And I shown the error. Okay. So here is the case. If you want to make it correct. All right. Now, let us proceed ahead. Sir, I need to create, I don't want to put this square brackets here 1, 2, 3, 4, 5, 6. Rather, can you do, is there any formula, or is there any, some parameter available by the help of which I can create multi-dimensional array? Yes, you can. For example, if I am available with np dot array 1, 2, 3, 4, this is a list. If I am saying n dimension equal to 5, nd min equal to 5, that means it will convert this array into 5 dimension. So you are defining dimensions from your side. Nd min equal to 5. And then if you print this array, print ARR and print the shape. See, this is 5 dimensional. 1 2, how many square brackets are there? 1 2 3 4 5. Okay, 5 square brackets are there. So it is 5D, 5 dimensional array. And if you want to print the shape, how? See, in one row there are 4 elements, 4 columns. Row 1 4 columns, and remaining outer are axis. Outside there is one more axis, and outside there is one more axis. 3 additional axes are there. That is why it is multi-dimensional array. So remember, numpy equates multi-dimensional array. Okay, so right now we are representing how multi-dimensional arrays are created using numpy. You can give nd min. Okay, and now you will say, sir, is there any other possible chances? Can you have some more codes related to it? Yes. If I say 3, so it will convert it into 3D. This is the 3D. Okay, if you are available with, sir, let for example, if I'm having this thing, comma, if I'm having 5 6 7 8, like this I'm having. So this is already 2D. This is already 2D. I say convert it into 3D. Let me run this code. Now it's converted into 3D. Already it was having 2 rows and 4 columns. Now it is 3D. Here you can check. 1 plus 1 additional axis has been added here. Okay, fine. And if you say, sir, how elements are organized here, sir? If I put a question, Sir, how elements are organized? Sir, you are doing and we are understanding, okay, dimension. Sir, how elements are organized? Can you please let us understand? Can you visualize this stuff? How elements are organized? Okay, so let me create a whiteboard. Okay, start a whiteboard and help you in understanding. See, I have shared whiteboard with you all on your mail. You can join it. Okay, if not, I'm sharing my screen. No worries. Okay, I've created a whiteboard. Okay, let me explain you things on the whiteboard. If you want, you can join. Else, no worries. I have shared this thing. Here is the whiteboard. All right. So, the point is, if I say an array, a 2D array. Okay, so 2D array has been represented like this. 1, 2, 3, 4, 5, 6. And what is the location of this one? Sir, 1 is represented by a 0 0. What is the position of 2? 2 is represented by a 0 1. What does the 0 means? This is C. This is 0th row. This is 1th row. This is 0th column. This is 1th column. This is second column. So if I say what is the location of element 1? So the location of element 1 is 0 0. What is the location of element 2? The location of element 2 is 0 1. Location of element 3 is 0 2. What is the location of element 4? 1 0. 5 1 1. 6 1 2. If I say, sir, I convert this thing into 3D. If I convert this thing into 3D, that means one more dimension will be added. So if this thing has been converted into 3D format, so one more additional dimension. So one more additional dimension. Then if I need to represent one, where is one present? So one is present at this location. A 0 0 0. This is where the A is present. If I will say, where is 6 present? So 6 is presented A 0 1 2. This is the location of 6. Okay. So now this 2D is converted into 3D, and here is one more dimension I have added. This 0 0. One additional dimension. So twist can be made anything because it is a multi-dimensional array. You can add a twist. If I would say, sir, convert it into one more dimension, sir. One more dimension here. So where is now one present? One will be presented a 0 0 0 0. This is the location of A. That means in 2D you have added two more dimension. Now it is 4D. This is 4D representation of element 1 where it is present. Element 1 is present. If I do talk about 6, then it will be A 0 0 1 1 2. This will be the location of 6. A 0 0 1 2. Okay, so multi-dimensional is being a bit complex. The thought is, I told you, if you're able to imagine or not. If you're not able to imagine, that's why I created this case for you. How to represent an array. How to find the location of element in an array. So this is how you can locate. Did you understood this thing or not? Students, please give me an answer. Representation, array representation of elements.
Understood, sir.
Okay, I can't hear the voice of all the students. Can I hear the voice of all the students?
Understood, sir.
Yes, sir.
Yes, sir. Understood, sir.
Understand, sir.
Yes, sir.
Okay, okay. So Fine, let's get back to our coding part. Okay, just to make you aware of this thing, I created this whiteboard. Okay, now practice code again. Fine, let us proceed ahead with your the next thing, that is the reshape method. Reshape. So see, it is again very important method, reshape, to understand. For example, if I am available with the array arr np dot array 1 2 3 4 5 say up to 12 elements, I need to reshape it. Arr dot reshape 4 3. See, reshape. See, reshape can only be done according to the possibility. Okay, if I am available with the 12 elements, I can organize it into 4 rows and 3 columns, because 3 fours are 12. I am available with the 12 elements now, so I can organize into 3 into 4, 4 rows 3 columns, or 3 rows 4 columns. This is also possible. If I would say copy, and if I would say paste it here, if I say new arr1, I can write it here as 3 4. This is also possible. And 12 elements are, you can organize into 6 2 and 2 6 also. This is also possible. That means paste it here again. If I create new AR2, that means I can have 2 rows and 6 columns. Okay, and one more possibility. New AR of 3, I can have 6 rows and 2 columns. This is also possible. Okay, so all these reshapes are possible. Let me print this. Okay, this is new ARR. If I print new ARR1, it will print you like this. Okay, that means 3 rows and 4 columns. If I print new ARR2, it will print you 2 rows and the 6 column. And if I print new ARR3, it will print you 6 rows and 2 columns. Now if you try, sir, can we have an odd shape? You are available with the 12 elements, and whatever be the possible combinations are, you have performed the reshape here. Now if I need to reshape it by 1 5, for example, 1 5. Okay, let me run this code. You know about this fact. Can we reshape? See, we are available with the 12 elements now. So the possible combination with the 12 elements of reshape I have done. Now you're saying, sir, reshape it by 1 5. That means 1 row and 5 columns, sir. So no, not possible. Cannot reshape 12 into shape 1 5. Not possible, this thing. You can't do this stuff. Okay, so this is logical, quite logical. How many elements are there and what is the possibility of reshape? So this will give an error. Okay, can't reshape. So remove this thing. Okay, now next code. Still, I am having much more possibilities. See what? Again, I am having 12 elements. And right now, here I am performing reshape with 232. 232. That means previously I did reshape. That means I reshaped this stuff into 2 dimension. Now you say, sir, can you reshape this into 3 dimension? Is there any possibility for reshaping it into 3 dimension? Yes. 2 3 2. That means I am having 3 rows and 2 columns internally and 2 rows externally. So 2 3s are 6 and 6 2s are 12. Sir, possible. Again, see what kind of combination you have prepared. 12 elements. I should get final result as 12 in multiplication. So 2 3s are 6, 6 2s are 12. So you can understand here what kind of matrix you got. 3 rows, 2 columns. See, 3 rows. Row number 1, row number 2, row number 3. 3 rows. And 2 columns are here. Column 1 and column 2. Done. But outside also you got two more things. 2. So 2 means this is represented by 0. This whole is represented by 1. So this is outer dimension 2. And if I would say What is the location of 1? Can anyone tell me what is the location of 1? What is the location of 1? Anyone of you can tell me what is the location of 1?
1 0.
How much? How much?
Zeroth row, first column.
Zeroth row,
One one
first
zero.
call. Okay. Are you sure? 1 1 0 or 0 0 0? If I do print,
All zeros, sir.
if I do print new ARR, what is the element present at 0th row? Also 0th row and also 0th column. Okay, let me print this thing. It's a invalid scalar. You can't use like this. So what could be the possibility? Okay, sir, separated by comma. Is it possible, sir? Is it possible by separated comma? Let me run this code. Again, it's a too many indices. It's not possible. So you can't print element like this, like zero thing and then zero thing and all this. But in general notations, in case of multi-dimensional arrays, we do represent the same thing. We do represent all this particular notation only, like 0 0 0. Okay, just to show you that what is the possibility. So this is your 0th row and this is your 0th column, and outer is also 0. Outer one is also 0. And if I would say what is the location of 12, so the location of 12 will be 1 and 1 again, 1 1 and 1 1 1 1. Why? Because 12 is present at, okay, if this thing represents 0, so this thing represents 1, because outside you are having two dimensions now. So this thing be represented by 1. Done. 12 is present here. That means this is 0th row, this is 1th row, this is 3rd row. Okay, that means I need to have a change. Should be 2. Okay, so 0 1 and 2. And then what is the column? This is 0th column, and this is 0th column, and this is 1th column. So I should have to write it as 1. So 1 2 1. Okay, so if you want to print the shape also, print new arr dot shape, run this thing. Its shape is 232. Already I have reshaped it, so its shape is 232 only. Okay, and your element present, this 12 I already told, at 1th. Okay, so always indexing starts from 0. You'll ask me, sir, why you use 1? You guys are saying, sir, this is 1. No, indexing always starts from 0. Okay, and later ahead we will print these elements. Okay, so just right now, listen carefully, understand how it has been represented. So this is the 0th and this is 1th, first case. Then this is 0th row, this is 1th row, this is 2nd row. Again same thing, 0th row, 1th row and 2nd row. Then this is 0th column and this is 1th column. Always indexing starts from 0 in case of array, you know that. And rows and columns also indexing starts from 0. That's why I told this is 1. That means overall this is 1th. And 12 is present. 12 is present here, which is at the 3rd row, which is actually represented by 2. And in the 2nd column, that is actually represented by 1. That's why I wrote new ARR 1 to 1. This represents 12. This is represented as 12. Okay. So one possible combination to perform a reshape 232. What are the other possible combinations? Let me copy this code and print it, put it here. What are the other possible combination? Do you have any combination? If I write that like there is 6, and if I write here is 3 and 4, Is this a possible combination or not? 1 3 4, what do you think? Is it possible combination? Any idea? Is this gonna work or not? 1 3 4.
Yes, sir.
Okay, because the multiplication is 3 fours are 12. Okay, let me run this code. It will work. So outer dimension is only 1. I got it. This is outer dimension 1. And inner is 3 rows and the 4 columns. Okay, and if I do have a change again, copy and paste it here. If I say, sir, 3, outside make 3. 3, then make here is 2, then make here is 2. Is it possible? 3 2 2. Is it possible? 3 2 2.
Yes, sir.
Okay, so again the multiplication is 12 and you got 12 elements. So it's possible. What will be the output? 3 means outer side is 3, na? So this is 0th, this is 1th, and this is second. And 2 2 means, okay, 2 means, this 2 means 2 rows, na? So this is 0th row, this is 1th row. Okay, 0th row, 1th row, 0th and 1th. And what is this 2? 2 column, na? Column 1, column 2. Okay, column 1, column 2, and column 1, column 2. So this is 3 2 2. Now, if I would say, where is 12 present? Can anyone tell me where is 12 present? How to find what is the location of 12? What is the location of 12?
2,
Okay, 2,
1,
2, 1,
1.
2, 1, 1. Okay, good. 2, 1, 1. 2, 1, 1 is the location of your 12 element. All right. Fine. So this is how, we are performing reshape. See, reshape is very important. Again, because when we are available with the data, we do convert it into your various it's sometimes it is mandated to perform the reshape. Okay, then correct reshape is something which is required, and we give input data to the model also. So this is important thing, this method. Okay, let's proceed ahead. I guess this is the here are I'm available with the 9 elements, and I perform reshape with 3 3. So you know that 3 3 is possible. Number of elements, the multiplication, this multiplication should be equal to the number of elements, then only reshape can be performed, else reshape can't be performed. Okay, so I guess this is quite easy. And here I am printing, see, I took this array and I'm saying arr dot reshape 24 base, arr dot reshape 24 base. So what is the base array of this? See, it will be reshaped 2 4. There are 8 elements. So if I would say copy and paste it here and print it here, print. So what it will do? It will reshape your initial array in 2 rows and 4 columns. And here, what is the base array of it? It's going to print it. So let me run this code. Okay, here the reshape has been performed of 8 elements. These are all 8 elements. Its reshape is performed here. All right, but what is the base array of it? So it's going to tell me, okay, sir, this was the base array. This is how you have performed reshape. Okay, so reshape 2 4, or rather I can use 4 2 also. No worries. 4 2 also. It will perform. Now 4 rows and 2 columns. If you say, sir, don't do this, 2 2 2, I guess this is also work. 2 2 2s are 4, 4 2s are 8. Convert it into 3D. 2 2 2. Let me run this code. Yes, it will. And all are having the base arrays 1 2 3 4 5 6 7 8. Yes, all will be the base array. Okay, and now I have converted into 2 2. That is 3D matrix with the reshape. Okay, I hope this has also been clear to you all. Now, sir, reshape with a minus value, sir. Sir, till now you have shown, sir, positive values in the reshape. Now, what will happen, sir, if I use minus value? For example, here I am 8 elements, and I am using reshape 2 2 minus 1, 2 2 minus 1. So, what does this mean? Here the reshape has been done actually in the same format as I did perform the reshape as 222. Here it is. Same reshape has been done. With just like 222, it is 22 minus 1. You can see the results. It's a 3D only. Okay, so if you are going to take minus 1, that means you don't have any idea how much reshape I can do. And you entered a value minus 1. Then also it will organize it into the as per required. What is the possibility? If you don't know, you put a minus 1 here. What next I need to write? I don't know. You put a minus 1 here. It converted into 3D. Okay, and here also. In this case, understand, very important, understand. You will say, sir, only minus 1 is possible, sir. For example, if I do write minus 2, if I do write minus 2, shall it work or not, sir? Let me run this code. Then also it will run. So, if it is minus 1, minus 2, minus 3, whatsoever, if you don't have any idea that what next this reshape can be performed, you are using this minus sign and it will automatically reshape it. Okay, and if you say, sir, can't we use minus here, here, is there any possibility? Okay, let's do. Whether it is been possible to the last value or whether it is possible to this thing also. If I say minus 2, 2, 2. Is it possible here also? Yes. So you can use negatives also in the reshape. But it will reshape it into actual format, which was initially like this 2, 2, 2. And if you don't know what are the other possibilities, you can use minus sign. If you say, sir, if I use minus 1, and minus 1, run this code. It will say only specific one unknown dimension. So I was, I told na, if I don't know the dimension, I'm using minus 1. But how should I tell you that I'm using this thing? By creating error. I created error. And error says value error. Only one specific unknown dimension. One dimension, if you don't know, then you can use minus sign. So minus sign can be placed anywhere. Okay, and let me run this code. Now here it is. What is the whatever be the possibility? See, one means okay, one row, one column, something like that. So it created a possibility. Here is a possibility. This is how you can organize elements also. So here one dimension you don't know. So you from your side by default put minus 1, and let the machine decide how to organize it. But only one dimension. Don't try to put, sir, I don't know any all the dimensions I don't know. No, not possible. Okay, so here also the same stuff done. Minus 2. And you organize it into this way. Okay. If you say, sir, this is a matrix, 2D matrix, and I don't know how to reshape it. So I just use reshape minus 1. Okay, and it reshaped this in this way. Because I use only one parameter, na? Minus 1. So that's why one axis has been created. Okay, so this is the possibility. Just use reshape minus 1. So it converted this 2D into 1D. Okay, for example, if I do have something else. For example, if I'm having this thing, just use one more bracket here, one more bracket here, one more bracket here. Okay, so now it is a 3D. And if you want to perform reshape minus 1, that means it will convert 3D also into 1D. It's all possible. If you say, sir, I am available with comma 7, 8, 9. Okay, then again performing reshape, no worries. It will again convert it into 1D. So reshape minus 1 will convert into 1D. If you are having 2D, 3D, 4D, what you are having, understand what we are doing. Reshape minus 1 converted into 1D. Upper dimensions to lower dimensions. Okay, and now if you say, sir, are we using only reshape minus 1? Sir, can we use reshape minus 2, sir? Whether the result will be same? if I use reshape -2, whether the result will be same? Yeah. Then also you are going to get the same results. Okay, fine. Here, in this particular example, we have already proceeded ahead. For example, if you are having a 2D list, okay, this is actually a list, and you are creating a 2D array with that, okay, and you are printing it. So it's a 2D array actually. It's clear. It's a 2D array because two brackets. So it's a 2D array. Simple. No operation done here. Nothing. Just giving list as an parameter to array and converting it, making it as array. Here, if you are available with again 2D, convert it into 2D. And if I say array 1 equal to array 2 and printing array 2, so it's a copy. I am creating copy. Previously, we have seen copy method. And if I say array 2 equal to array 1, this is also copy. Okay, this is also copy, and new array value is same as that of the initial array. Okay, so creating copy of an array without using copy method. But there is a twist. Now, create a twist. I am copying. This is your array 1 of these elements. You created copy array 2 with the same elements, and you updated the value of array 2. At 0th location, you said now it is 11. You updated the value of array 2, and you printed updated value of array 2 and updated value of array 1. See, changed, both changed. That means array 2 equal to array 1 is actually not a copy, it is a view. If you assign array 2 by array 1, it is a view, not a copy, not a simple copy, because you have updated the value of array 2 and it automatically updated the value of array 1. So it's a view. Okay, so this thing is needs to be understood. Here the updation done, and here you have assigned the values, so changes. All right, now let's proceed ahead. Again, I am having array 1 with these elements, 2D array. Okay, I printed its value, I created view of it, and I printed this is the value of array 2, and I performed array 1 dot shape equal to 1 minus 1. Okay, that means I reshaped it. Array dot shape equal to 1 minus 1. That means converted into 1D array. Will the changes will reflect on array 2 also? Here it is. Yes. If you have performed reshape on array 1, converted it into 1D, then definitely array 2 will also be converted into this particular thing. Now it's a 2D actually, but you know what happened? What happened? 1 comma minus 1. That means you have applied a transformation. Previously, if I would say, it's been represented like this. That means this is 0th row, this is 1th row. Now everything, this is 0th row and this is 1th row. Now what is this? Only one outer row is present. Okay, and everything, this all will come into one row. Okay, so if I would say now, if I would ask to someone, what is the value of 6 here? What is the location of 6? Anyone can tell me what is the location of 6 here? It's a 2D.
0, 1.
Oh, okay, 0, 1. Wait a minute. How much you told? 0?
0, 1,
1?
2.
Why? Is it a 3D?
Oh, no, sir. 0, 1. I'm focusing mainly on 6.
See here. 2 brackets, na? So it is 2D, obviously. So if I would say this 6, so 6 is present in row number 2, na? This is present in row number 2. So how you can say, sir, this is 0?
Row number 1, 0, 1.
That means row number, obviously it will be 1 now. See, this is present in row number 2, so which is actually called as 1. Okay, because this is 0th row and this is 1th row, so this is 6 is present at 1. And what is the column value? This is zeroth column,
Two,
this is
sir.
1th column, this is second column. So the value 6 is present at 1 2 position. Now tell me here, where 6 is present? Where 6 is present here?
Zero through
Where?
0, 5, sir.
0?
5.
5,
Very
sir.
good. 0 5. Because here I am available with only one row. So 0 5. So transformation done. This 1 minus 1 has reduced one, has transformed it into from this particular thing to this particular thing. There's a reshape done. Okay, and with this reshape, now the position of 6 will be it will be 0 5. So you are absolutely correct. It's 0 5. Previously 1 2, now 0 5. I hope it's been understood to all the girls, because I can hear the voices coming. I don't know what the discussion is going on. If you guys are having any doubt, please let me know, because these are very important things to understand. Okay, very important concepts. All right.
Sir,
Yeah, yeah. Say.
sir, sir, can you explain that the value of array 1 again, sir?
Array one. Okay, value of this array
I
one.
mean, the sixth
Yeah, sixth. No, see the point is
position of 6,
it
sir.
is it is at the zeroth location. This is at 0 because it's a 2D matrix. Okay, it's a 2D matrix. So this is 0th row and this is 1th row. Okay, so if this is 1th row, na, so and what column 6 is presented? What column number? This is column 1, this is column 2, and this is this is 0. Start from 0. This is 0th column, this is 1th column, this is second column. Okay, so 6 is present at second column and 1th row. That is why 1 2 is the location of 6. Here, if I would say only one row is there. So only one row is there. That means it is represented by 0. And if we do talk about the column, so this is column 0, column 1, column 2, column 3, column 4, column 5. So 6 is presented 0, 5. Okay, and here it is presented 1, 2. Now you understood or not?
Understood, sir.
Always indexing starts from 0 for rows and columns both. Okay, so just and understood by that thing only. And here I created a view. That means view not only if it do update a value in the views then also it will change its value. And if I do update the the shape of this array, then also the shape will be reflected back. That's also possible. Okay, let's proceed ahead. Okay, here the view has been created and we very well know about the view. Now view will definitely change. Okay, so this is your array 1. Okay, I have printed this array 1. I created array 2 with a view of array 1. Okay, and when I'm printing array 2, here it is. We have already seen this stuff. And the same thing, if I created a view of array 1, okay, and I update the value of array 2 by 11, then obviously it will be reflected back to the original array also. We have already checked this stuff above, that view reflects the updated values in all the arrays. Okay, so here is your view. And if I do assign array 2 equal to array 1, that means it is a view. It's not a copy. That those examples also we have seen. Okay, so all these are this view stuff. Here also reshape done. Okay, and here also no, there is one thing. Just do have a check. Here this is list. Okay, you converted it into array and you create a view of array 1, that is array 2. You created a view of it and you performed a reshape of array 1. And here the fact is, one thing happened. You updated array 1, but array 2 doesn't changed. Previously, when you have assigned array 2 equal to array 1, then reshaped applied on both the cases is applicable. But here, when you use a view of array 1 as array 2 and performed a reshape on array 1, But when you checked what is the shape of array 2, it doesn't change. Okay, so one thing we got to understand that if you are using view method instead of array 2 equal to array 1, then if you perform reshape in original array, if you perform a reshape here, then then the change is not reflected to updated to array 2. It's not been reflecting. Previously, when I was using what this stuff, array 2 equal to array 1, and when I change the shape of array 1, when I change the shape of array 1, then array 2 also got changed. Here you can see array 2 shape is changed. But when I am creating a view of array 1 in form of array 2, and I put a change in array 1, but shape of array 2 doesn't change. Difference. And we were understanding, sir, array 2 equal to array 1 is just like a view only, sir. But if I use view method, then things got changed, scenario changed. Reshape is not reflecting. Okay, so mark it down. This is important example. Difference between array 2 equal to array 1 and array 2 equal to array 1 dot view. Okay, things to be noted. If I create a copy, you very well know, sir, copy can be created. So this is your array 1, and this is your array 2. Yes, sir, copy can be created. Simple copy is created. If you update the value of array 2 in the copy, then it will not reflect array. See, if you update the value of array 1, then obviously it will not going to reflect you on array 2, because copy is a simple copy. We have already checked the examples above. Changes are not reflected back. Okay, so here you updated value of array 1 0 0, you made it as 11, a 0 0 11. Okay, so if I say here only, let me run this code. Okay, I've run this code, and if I say print array arr no array 1, array 1 0 0 0. Okay, if I say print array 1 0 0. Okay, so the value which is present at 0th index is 11 now. And if I say print array 2 0 0, okay, what is the value present? It is 1. 1 is present. Okay, so the point is you have created a copy of array 1, named it as array 2. You have updated the value of 0th index position value. At 0 0, you updated 11. Previously it was 1. Now you made it as 11. And then when you printed both the arrays, changes reflected only in array 1, not on array 2. And I have also printed individual values of them also, like this: arr1 0 0 and arr2 0 0. So this is how you can print the individual values also. Previously you are seeing the error now, because that code wasn't executed. That's why. This is the way to print, and I've already told you this is the way. When you are going through each and every code, when you execute each and every code, a sheet is available with you. When you are going to do the practice, then you will understand. Okay, and now again, sir, we have seen the concepts related to the reshape for the view. What will happen with the copy? If I say array 2 equal to array 1 copy, and I reshape array 1, will reshape is reflected to array 2 also? No. So I understood, sir. In view, if you perform reshape, not reflected. In copy, if you perform reshape, not reflected. But if you say array 2 equal to array 1, then value updation is also reflected and reshape is also reflected. Are you getting my point or not? Students, you got my point or not? Ramya,
Yeah.
understood?
Yes, sir, understood.
Rishmita?
Sir, understood, sir.
Okay, so this is the difference between copy, view, and assignment. Okay, so you should be knowing what's happening. Now, this thing I've already explained, array 2 equal to array 1. Okay, so just doing this by step. I assigned value array 1 to array 2 and printed array 2. So it's all same as array 1. And yeah, this has also been, we have discussed creating an array with the help of a list. So it's already discussed. Okay, and updation. While assignment, when you update the value a to array 200 equal to 1, then obviously it's going to reflect you in both the cases. This example we have already covered. Okay, and understood what is the difference between view, what is the difference between copy, and what is the difference between this assignment. So this will gonna reflect everything with this value also, with reshape also. Here, if I do assign array 2 equal to array 1, obviously changes will be reflected. We have already seen. Okay, with view, only value updated will be reflected, but reshape is not reflected. The point is already clear. So these are same set of examples which are coming. Okay, here reshape is not reflected. Array 1 will be this, but array 2 will all same. Okay, and copy I have already explained. With copy also, reshape is not reflected. In fact, the updated value is also not reflected in copy. You know about these terms. Fine. All right. So this is we have done. This is I have explained you. Okay, creating a list, creating a set. Okay, dimensions. Okay, now here it is. If I say, if I want to print what is the dimension of an array. So if I do take a equal to np dot array 42, 42 is a scalar quantity. I'm not putting it under any square brackets. So here 42 is a scalar quantity. So obviously its dimension is 0. See, dimension is added to the vector quantity. You very well know, you have studied in science also. What is a scalar quantity? So scalar quantities are those quantities which have magnitude but no direction. What are vector quantities? Or vector quantities are those quantities which are having magnitude and direction both. Okay, so here only 42 if we are giving, it's a scalar, so no dimension. If I would say one square bracket, that means I am giving a list here 1, 2, 3, 4, 5. It is having one dimension. If I put two square brackets, it's a 2D dimension. If I put three square brackets, it's a 3 dimension. Here it is a 3 dimension. And also just copy this thing, copy this and paste it here. Okay, if only I here write one square bracket more, one square bracket more, so this will also convert into, this will also be converted into 2D. I've already shown you previously. This is also 2D. And if I put one more square bracket here and one more square bracket here, this will be now 3D. So remember, dimension means count the brackets, outside brackets. If the outside brackets are 1, 2, 3, that means it is a 3D. Okay, so here it is a 3D now. 3. Okay, so you can print the dimensions by a dot endim. a dot endim will gonna print you the dimensions, number of dimensions. Okay, now next. I have also gave you this example. If I'm having NDM equal to 5, that means number of dimensions should be 5. That means you are going to convert an array. This is an array and make this into of 5 dimensions. So we have already seen this is a 5-dimensional array. Okay, and it's up to you. I have also gave this example previously. Okay, that means if you are available with the 2D, if you say ndim equal to 6, that means I need to convert this array. I need to create an array of 6 dimension with this input. This is the input. Convert it into 6 dimensions. Yes, you can. Okay, that means if you say ndim equal to 6, you can convert it 6 dimension. If I'm going to print the element, if I'm going to access the elements which are present in the numpy, okay, no issues. This is 1D array. If I say ARR 0, this will be 1, ARR 1, this will be 2, ARR 2, this will be 3, and ARR 3 is equal to 4. So this is how you can access the elements of the array. If I need to perform arithmetic operations, it is also possible within an array. If I would say I need to perform, see, this is an array of 1, 2, 3, 4, these elements. If I would say ARR 2 plus ARR 3, what is present at ARR 2? This is 0th index, this is 1th index, this is 2nd index. I am saying ARR 2, that means element present at the 2nd index, that is 3. Element present at the 3rd index, that is 4. So 3 plus 4, result is 7. So you can perform addition also within array. Possible. Okay, just adding the values present at the index positions. Okay, so now if you need to see print the shape like in this manner, for example, this is a 2D array. 2D array. That means if I would say what is the location of 4, you will say, sir, 0, 3 is the location of 4. So if I print the array, okay, this is array. If I print the dimension of it, sir, it's a 2D, 2 square brackets, no? Sir, it is 2D. If I would say what is the shape of this array, sir, 1 comma 4, sir. 1 row and 4 columns, sir. 1 comma 4. If I would say what is the element present at 0 0, you will say, sir, 0 0 is 1. What is the element present at 0 3? Sir, 4. This is also been possible to print the element. If I would say like this, print like this. Okay, 0 square bracket comma, instead of comma I just use this thing. Here also square bracket, okay, and put it like this. If I run the code, then also you'll get the same result. So it's up to you. Either you can use separated by comma, either you can complete it with the square brackets. It's up to you. Then also you can find the elements here. What that means I'm printing the elements at this particular locations. Okay, next, same thing. I'm having list 1, I'm having list 2. I created an array with the list 1 and the list 2. That is actually a 2D array. Okay, I printed its dimension, I printed its shape. Okay, dimension 2, shape is 2 5. Shape is 2 rows and the 5 5 elements, 5 columns. Okay, so 2 5. Total 10 elements are there. And if I'm going to print the value 0 0, so it will be 1. If I'm going to print 0 1, so it will be 2. If I say 1 0, that means it will be 6. Here it is. Okay, so you're creating an array, multi-dimensional array, you're printing its shape, dimension, and accessing the values also. Okay, now here the same stuff. What? Here is a list 1, and I created an array ARR using this list 1. Okay, and if I print ARR, so what it will be? 1 2 3 4 5. But what I did anyone understood what I did here? What is ARR 1 3? Anyone understood what happened? ARR 1 3. Did anyone understood what happened here? Because you are able to see the output 2 4. So what happened here? Anyone?
First, I mean, it will print 1 comma 3 elements, sir.
Huh? 1 comma 3 elements. Okay, yeah, it is printing. These are 2 and 4. But can you understand what happened? 1 and 3 element
Elements
I
present
mean,
in the
in
index
that position,
positions.
sir.
index positions. Okay, so it printed the element which is at present at the 1th index position, and the element which is present at the 3rd index position. That is actually 4. Okay, so we have used here a double square, this array double square bracket to print the elements. And if I just copy this thing, and if I use like this stuff, don't use double square brackets. If I say this thing, then what will happen if I run this code? It gave error. Too many indices for array. Array is one dimensional, but two were indexed. Okay, so this is one dimension, and you're saying for one printing one value itself, you're saying sir 1 3. That means there is no value present at 1 3. So you need to make it like this: one square bracket more and one square bracket more. Then it will say, okay, 1 3 na. So 1 is taken separately and 3 is taken separately. And if you don't use square brackets, then 1 and 3 are taken as 1, and it will say, no, 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 1 1 3. Your list is not, your array is not of that 1 3 dimension. It is single dimension only. So that's the difference. Okay, let me remove this. Okay, run this code. Your answer is 2 4. Okay, now how many dimension this is having? 3 dimension. Now if I'm going to print 0 0 2, you very well know, sir, this is one, only one row is there, one row and 3 columns. Okay, so this only available with 0th row, and 2 is the column thing. So this is 0th row. At column number 2, 3 is present. 3 is present, and obviously outer dimension is also 0. So 0 0 2 will be obviously 3. Okay, outer dimension is 0. So 0 0 2, it will be 3. If I'm going to take here 1 2 3 and 4 5 6, and if I say 0 0 2, so this is 0th row, 0th row, 0th row, and what, second. So in this row, what is second? 0th column, 1th column, second column. So it's representing column, it's representing row, and it is also, this one is also presenting row. So in this 0th row, this is 0th row, second column. So this is second column, element is 3. And if I would say copy, but I will not print, I will ask you 1 1. Okay, and okay, what will be the result? 101. What will be the result? What will be the result? 101. Anyone can let me know what will be the result? 101. Anyone? Result of this 101. Have I written correctly or not?
Will it print 2, sir?
Okay, see, if I do talk about 101, so 1, see, this is, if this is represented by 0, okay, this is represented by 0, this should be represented by 1. This complete thing should be represented by 1. One said answer me 2. No, I don't think so. If this is your 0th, so this should be 1th. In 1th, I am saying 0, 1. Now, what is this problem, sir? In 1th, you are saying 0, 1. If this is 1th and you say 0, 1, so so 0, the 0 means 0, 1 means 0th row. But sir, if I do take this is a 1, so this row is also 1 because initially this row is 0, this row is 1 internally. Okay, let me run this code, and obviously it will be error, out of bound, out of bound. So the point is, and I will show you on whiteboard also. I will show you this result on whiteboard. This is 1th row, not 0th row. So let us make it as 1. Okay. So 111 means this is the first one is complete this stuff. And 1 means this row. And this one means column. So this is 0th column. This is 1th column. Let us check the result. Still it is giving out of 1. Index 1 is out of bounds of x is 0 with size 1. Still there is some issue. Still it is out of bounds. So I can't take, it's saying you can't take it as 1. So if I do take as a 0, let me run this code. It's 5. That means the interpretation was outer was only 0, not 1. This was only 0. Don't consider this as 0. Don't consider this as 1. So interpretation was wrong. So 1 1 means 1th row and 1th column. So the element is 5. Now let me put this stuff on the whiteboard and explain you again that how this happened. So 1 2 3 and 4 5 6. Let me put this thing on the whiteboard. Okay, and explain you. I'm putting a whiteboard jam, creating a jam and explaining it. Okay, and let me reshare the screen. All right, so here it is. You got an array. Your array was like this: 1 2 3 and comma 4 5 6. This was an array. So it's been represented like this. If we have printed this array, it's looking like this: 1 comma 2 comma 3 and 4 comma 5 comma 6, and these are the brackets. So actually it's a 3D thing. 3 brackets are here, 3 brackets are here, so it is a 3D thing. Okay, 3D. But whole this stuff is present at 0th index. The third dimension is 0. Then internally, if I go internally, this is 0th row, this is 1th row. So if I would say, what is the location of 1? You would say, sir, 0, outer dimension 0, no? Then 0th row and 0th column. What is the location of 2? It is, sir, 0th row, 0th row outside and both, and 1th column. If I would say, what is 5? It is again, outside is again 0. It's not 1, it's 0 only. If you're interpreting when during explanation, sir, this is 0 and this, no, this is outside again, it is 0th only. So 0th outside dimension is 0. But actually Now internal in 2D case, in two dimension. Now outer dimension is 0, but when I come inside, then this is 1th row, because is this was a 0th row, this was the 1th row, and the column number is 1. So 011 actually represents 5. Okay, actually it represents 5. If I do change a slide, and if I ask you 1, 2, 3, 4, 5, 6, you will say, sir, at 0th location 1 is present, at 1th location 2 is present, at third position, that means at second index position 3 is present. Okay, now, so this is what your, if I say this is row number 0, this is row number 1, this is column number 0, this is column number 1, this is column number 2. Okay, so at 0 0 you will say 0 0 1 is present, at 0 1 2 is present, at 0 2 3 is present, and at 1 0 4 is present, at 1 1 5 is present, at 1 2 6 is present. Now if I add one more dimension, here, that will represent 0. So again, which I explained previously here, if I add one more dimension now, so 5 was present where? 5 was present at 1 1 na, with two dimension. If I add one more dimension 0 na, it will be here. So 5 is present at 0 1 1. That's what I have shown you in the example. Where 6 is present? Where 6 is present? Again 0 1 2. This is where 6 is present. So just you need to play with the dimension. I request you guys, if you have any issues related to the dimensions, this is just my request to you. Kindly do work upon this thing. Okay, dimension, and if you are having any issues related to the dimension, please do let me know. Okay, I will explain you the concepts again for the dimension. Okay, so here the output is 5, 0 1 1, the output is 5. Okay, so let me stop the recording.